Hello everyone, today our topic is logical instructions. These are the basic objectives. First one is define logical instruction. Second is define status of source and destination registers before and after execution of logical instruction. Third one is define status of flags after execution of logical instruction. And fourth one is state bit level effect of various logical instructions. Now first instruction is AND instruction, ANA or N. Second form is ANA M. And it's AND content of accumulator with the content of register in a first case, and in a second case it do ANDing function with content of accumulator, the content of memory. Now let's see an example. This is an instruction ANAB. Content of accumulator is ANDed with the content of register B, and result is stored into register A or accumulator. Now let's see in this example. Suppose initially or say before execution of this instruction, accumulator is loaded with this data AAH and this register B is loaded with 0F. Now this is the binary form of each register content. Now each bit is ANDed with the corresponding bit of register B and result is this. So after execution of this ANDing function, we'll get this result now which is available at this register A. Now carry flag and accumulator flag status is this after execution of this instruction. Now content of this register B is now not changing, is 0F, and the content of register A or say accumulator is result of ANDing of register B and accumulator. Now second instruction is this ANAM, in which ANDing of content of memory with accumulator and result is stored into accumulator. Now B3 is the content of memory which is ANDed with 55, and this one is the result which is now available at accumulator. Now this again AND function, but in this ANDing you can see this immediate ANDing means 8-bit data is available. So ANDing between the content of accumulator and 8-bit data and result is stored into accumulator. Now this is an example in which this is the instruction ANI 3F. So 3F is data which is now ANDed with the content of accumulator, and this one is the result which is now available or stored at the accumulator. Now this is again ANI 8-bit data, ANDing of 8-bit data with accumulator and result is available. Next instruction is ORA register, XORing the content of register with accumulator and result is stored into accumulator. This is an example in which you can easily understand the status before execution of the instruction and there is a status of register A and register C after execution of this XRAC instruction. So it is doing XORing with the content of accumulator and register C and result is available at accumulator. Next is XRAM, content of memory is XORing with content of accumulator and result is available into accumulator after execution of this instruction. Now next is this example. Now say before execution, memory location 2050 is loaded with data B3 and accumulator is loaded with 55. Now this is the binary format of 55 and B3, and this is the result after XORing between above two registers content, and this result is now available into accumulator. Result of this memory location will not change, it will remain same, and this is the status of carry flag and auxiliary carry flag. Now this is XOR instruction, XORing 8-bit data. So one content is 8-bit data which is part of the instruction, and second data is at accumulator, and XOR result is also available at accumulator. Now this is the result. Example XRI 39. 39 is data which is XOR with the data of accumulator and result is available into the accumulator, and you can see here this is the result which is now available at accumulator. Is the status after execution of the instruction. OR instruction. Now ORA register, content of register is OR with the content of accumulator, and result is now available into the accumulator. There is an example. You can see here very well. ORAB. B content is OR with the content of accumulator, and result is available into the accumulator. Now this is the status of register A and register B before execution of this instruction, and this one is the result of register A and register B after execution of the instruction. Register A means it's nothing but accumulator. This is XOR memory. Content of memory is OR memory. Content of memory is OR with the content of accumulator. Now this you can easily understand. This is the before execution status. This one is the after execution of the instruction. Clear? You can see here and you can find out the result also. Okay? Understood? Yes. Let's see the next one. Is ORI 8-bit, ORing of 8-bit data with the content of accumulator. Now this is the result, or say example. This is an example. In this example, ORI 08. 08 is data which is now OR with content of accumulator B3, and this one is the result which is now available at register A or accumulator. Now this instruction is compare instruction. CMP register. Content of register is compared with the content of accumulator, and result is stored, and store the result in accumulator. Now see here, this CMPB, this content is now compared with the accumulator. Now before this instruction, let's see this one. If the content of accumulator is greater than the content of register, these are the status of carry flag and zero flag. If A equal to R, content of accumulator and content of registers are same, in that case carry flag will remain into zero state and zero flag will set. If content of accumulator is less than the content of register, in that case carry flag will set. Okay, now this, let's see an example. Content of accumulator is BA, content of register D is B9. So BA is greater than B9. So content of accumulator is greater than the content of register. So this one is the status. Carry flag will remain 0 and zero flag is also 0. Now see the second example. Compare memory. Content of memory is compared with the accumulator. Now suppose content of accumulator is B8, content of memory is B8. So this condition is satisfied, A equal to M. In that case, you can see here zero flag will set. You can see here after execution of the instruction, zero flag will set. Now this again compare instruction but with 8-bit data and accumulator. Now you can easily understand now this example. There's no need of look at this instruction. Okay, you can see here. Next instruction is STC instruction. It's set carry flag to 1. Okay, we can forcefully set carry flag to 1 using this instruction STC. Initially, suppose carry flag is 0. So after execution of this instruction, it will move to 1. CMC, complement the carry flag. So we will take the complement of carry flag. Now initially suppose carry flag is 1. So after this instruction we move to 0. RLC. Rotate accumulator left. Each bit of accumulator is rotated left by 1 position. Bit D7 is placed in the position of D0 as well as in the carry flag, and CY is modified according to the bit D7. Now see an example. Suppose this is D0, D1 up to D7. So after execution of this instruction, each bit will move to left, content of B7 move to the carry, at the same time will reach to B0. So this one is the status after execution of the instruction. You can see here B7 move to the carry, at the same time to this B0 status, and each bit is moved by 1 position on its left. RRC. Rotate accumulator right. Each bit of the accumulator is rotated right by 1 position. Bit D0 is placed in the position of D7 as well as in the carry flag. Carry flag is modified according to the bit D0. Okay. Now this one is D0. After execution of this instruction, after execution of this instruction, each bit will move on its right. B0 move to the carry as well as to the B7 position. So this is the status after execution of the rotate right instruction. RAL, rotate accumulator left through carry. Each bit of accumulator is rotated left by 1 position, is now through carry. Right? So bit D7 is placed in the carry flag, and carry flag is placed in the least significant position D0. Carry flag is modified according to bit D7. Now this is an example, can very well see in a diagram, and one can easily understand this. Okay. Now rotate right with carry is again very similar to previous one. In a previous one it was left rotation. Here this one is right rotation, and this one is through carry. Okay, you can see here in a graphical form what will be the status after execution of this instruction. Now thank you all. This is all about logical instruction. Have a good day.